Yeah, hi people. So in the following videos, we will be talking about solid principle. So what is solid principle? So solid principles are basically five principles which are used for object-oriented class designings. Like they are basically set of rules and best practices to follow while designing a class structure, object structure. So whenever we are solving any OOPS problem, these principles helps us to structure our code in the most efficient way. These principles provide a certain guidelines, like which are the right way of doing certain things and all. Basically, Robert C. Martin, who is also called as Uncle Bob, introduced this principle first time in his book on clean code or on agile development. Or so there we got the idea about the solid principles. And as in the image you see, right, five pillars. Solid is an acronym which is the first word of the five principles which are being said inside the solid principle. So we will see those principles one by one, and then we will try to code an example on that and see how we can implement that principle and make our code better out of that.
Yeah, hi people. So in this video, we will be building a banking app, and then we will be using step-by-step solid principles to basically improve the design of a banking app. Like we will start with with single responsibility principle, and then we'll go with other principles, and we'll start applying those principles on this banking app and try to improve the design. So yeah, let's get started. I'm building a banking app. So my first goal is to basically able to I have created my banking app project folder and a banking app test, and start by creating my first test, which is on where I can say in a banking app should be able to deposit able to deposit money, able to deposit money. Banking service, which will be handling this for now. Later on, we will see if we can do something else, but for now, let's have a banking service and introduce a local variable for that banking service. And I can say to create a banking service class in my coding folder, right? Can add it this to it, and then I can say just try to deposit money. I can say deposit money. For the system simplicity of this, let's have a bank account here. I can say new bank account. Now let's create a bank account object. Right. Okay. So in a bank account, what I can want is like what account number. I can say any random account number, right? Account number. I can do any phone number, and then I need the name of a person. It can be any person like John or some who is a customer on whose name the bank account is, and his mobile number. What else we can have? We have an email of that person. I can say John. Take a help of IntelliJ and try to place this class. Let me just do it. Let's just move it in a separate variable. Name it as bank account, and here I can just create a bank account class if it's possible. I can have all these fields. This is string. Just don't ask me again. Add this in here. Account number. And say name, mobile number, and then I'm just saying last thing is email. Let's take IntelliJ help to create fields for this bank account, and then I can simply make banking service accept a bank account, which is cool. You can just create a property for a field for this. It is cool. We have a bank account, and then now we should be able to deposit money, and the money I have deposited of double type. Here I can say amount. Now here I can say bank account. Banking service is using to deposit money, so I can simply deposit money salary. Now and I can simply test. Let's just not I can say just that equals to I'm expecting 5,000. If this banking service to get my money balance, account balance. So I can just go to this. Google tell my right. Now if I run this test, easily it will fail. But let's make it pass. I can say first go towards deposit money, and then inside my account I can say that money say set balance. And here inside this I can simply say account dot get balance plus amount. Simply adding the money. So let's see. It creates set balance method, and there also I can simply get done. It's set, but yeah, as of now I don't have any balance property in my class. I can take help of it. Additionally, get a balance property. Get a variable balance. It's of double type because balance can be large. Here I can separate under balance. Balance, and here I can simply set my balance. It's not balance. Is it final? No, yeah, I don't put it final. Here I am my balance thing. I'm just taking help of this and setting my heading balance and heading one bit. I'm hoping this will work and make it balance. Account balance. So simply that amount dot get balance dot get account item yes, and see whether it is passing or not.
Yeah, so now let's try to withdraw the money. I can say I have the same account number. I have deposited this much money. Okay, since this thing is same, right? So let's create a setup method and move these three things there. So before that, I have to make these as a global field. So I can make these, just make this as my global field, bank account. Okay, account is also fine. I can make this as banking service, not service, banking service, and then yeah, now this can be moved to my setup method if it has been created. If not, then I can create a setup method here, which will be called before any test. Our test enable first call the setup method and will then end the test. So basically, these values will always be setting up for us. So like if we want to test it, we can end this test and see. So yeah, it's running. We are good on this. Let's just delete this thing because setup is already been handling it. So yeah, we have the amount. Now let's try to just delete the amount. So I can use a banking service to basically withdraw money. I can say withdraw money. How much money I want to withdraw? I want to withdraw. Okay, so banking service already has account, right? So I can withdraw 2,000 rupees, and then I would be left with 3,000. Let's see when let's get a withdraw money method, right? And I can name this as double amount, right? Now let's simply do this. Let's say whatever I can just remove, change this typo withdraw money, money, right? Withdraw money. And here as you can simply say this dot. You can say count. From account I have to just say set balance, and I can say amount. For simplicity's sake, I'm avoiding like the checking the zero balance. So like even if the balance goes beyond that, then I'm okay to go with that. We can say this dot set balance and say this dot get balance minus amount. Let's see whatever test is passing now. We are okay with return money. Now and we are printing and then we can print the passbook also. Let's create a test to get the passbook data. I can say should able to get print data for passport. Like I can print it, but for simplicity's sake, I'm just getting the print data for passbook. Get also able to print data for passbook, and I'm just printing for simplicity's sake, I'm just printing the current balance. I'm not printing the history. And just printing. So I can just say I can say simply decide. You can simply say what I'm expecting. I'm saying expecting like current balance is how much. Whatever balance I have in my account, I would be expecting that. Like so say current balance is 5,000 because as of now I'm not withdrawn this right. In my setup, I'm just adding the 5,000 balance, right? Current balance is 5,000. This would be my return text from the get passbook method. Say bank service get print that passbook print data, and I can just create this method passbook print data, and I can simply say here I can just have my balance here, check account, and we should be good. Let's see, I can address see that passing or not. This also passed, right? Yeah, so this also it failed. Okay, so I'm getting a double value, right? That I can rectify. I can convert this to okay, so let's convert this to double also. 5,000 because yeah, I'm getting double, right? My balance isn't double. Yeah, this is fine. Need to get the loan interest amount. And like I would be having based on the loan type, I should get my loan interest amount. Okay. One more test I can say get should get the loan interest amount, right? Here I can simply create those many tests. I can just delete first this, and then I can simply create those many tests to check different loan types. So I can say expression dot if equals to, I can say for home loan, it will be, let's say I can say 8% for what? When saying, well, let's make it 6% for what? 7%. And I can say what? You can use the banking service again and say get loan interest, and inside the parameter I would be passing a loan type. So I am saying housing loan or housing, let's better name it as home loan. If it is home loan, then for simplicity's sake, I'm just passing string, but in actual app, we can use some constant or some enum to declare types. And I can get the loan interest. I'm expecting it to be 7%. So I can just create this method for now. And it will return me long or float because it's a percentage, right? So it cannot go beyond 10. I can name it as percentage, return percent, or interest percent, right? I can say here I have to pass loan type, right? For which loan I want to have the loan, and this I can name as then loan interest info. I can say that loan interest percentage, interest percentage, fine. For now, just put this thing, return something is here. Let's go back. Problem. Get loan interest percent. Loan would be 7. For a car loan, it would be 9. What a nice bank, right? And then for personal loan, it would be 12. I can say 12 for personal loan. Personal loan, right? We are very good to go. Let's see. Let's send this once. And I'm getting 7, but I'm getting this. With the side, I can simply fix. I can say if I can have a switch case here, and then on that, based on it, I can have the case for loan type, and I can say if case of loan type is home loan 7. Let's see whether it is even running or not for this. If I'm thinking whether switch case is passing, let's take a help for avatars and see. Okay, a switch case is passing, so I can have all the cases. Home loan is this, and then for car loan it's 9, and then for which personal loan I can pass 12. And if there's any other loan, I can simply give it as 15%, and I can also use default, but yeah, this is also fine. I can simply say this, and let's see if my test is passing now or not. This looks nice to me. Now what else I want to do with my banking service, with my bank basically. And now I want to send the OTP to a bank. So I want to send the OTP. So I can have one more test, and I can say, so able to send OTP. Able to send OTP to mobile, right? Then I can simply create a OTP method, banking service, and I can just send. So able to send OTP to mobile. I can say send OTP. I can send OTP, and I can say some message if you want, some dummy message in my OTP message if I want. I can pass that, and then I can expect what I'm assuming method will also be returning me something. Yeah, if I simply say I'm assuming like this will also return me some message only, so I can have a session here now. This is a session, not a session. I can have a session. For simplicity, I'm assuming in real world, I would be using some OTP or some messaging services like Tulo or something, but in this, I'm just assuming like it will simply return me a statement like the message has been sent to this one. So I can say send as that equals to, I can simply say banking service dot send OTP, and I can simply say it will return me message sent to this phone number, message sent to this number. I can simply reply like OTP send. For now, let's just remove anything. I don't want to pass anything. OTP send to this number, right? And then I can simply say send to this number, send to the number, OTP sent to the number, and number I can take it from where? From my account, right? So I can simply say account plus account, not I have to need a phone number now, right? I can say if I have a phone number, get mobile number somehow, then I would be good. I can see, let's see if I can get somehow mobile number. Would be good. More than happy for that. I can here simply say just return my mobile number. Mobile number would be a long, right? So I can simply return my mobile number, right? Cool. Send there, so I can also have it as int for now. And I can go back, get my mobile number. Now the send to OTP method I can create, which will basically return a string for me. As of now, the test will fail because I'm not returning. Let's just return the same method. I think I just need this thing home. And where was I? I was here, right? Let's just move this test to second line for better visibility. I can move this thing here. I can simply say place OTP, and here I can simply return the particular skin that I have created there. And I can simply end this thing. Let's see if my test is passing now. My bad. I can end this test once again. So pretty much my complete, like I've added lots of functionalities to this banking game, and particularly to banking service. Like I can basically now deposit money. I can withdraw money. I can print data, or basically get the balance of my account in the textual form, and then I can get the loan interest amount. I can simply say get loan interest. It can tell me like it's 7%, 9% or something. And then I can send OTP messages. So this is pretty much my banking service class till now. So the first solid principle is SIP principle. Or here, like the S letter in the solid, right? That stands for SIP, which is single responsibility principle. So single responsibility principle states that a class should have only one reason to change. Like if something is changing, then a class will only change if a single thing is changing. Suppose multiple things are changing, then the multiple classes should change. Like there should be not more than one reason for which a class is changing. In a way, it says like every class should have a single responsibility or a single job or a single purpose. So if that purpose is changing or that job is changing, then only that class will change. Something else is changing, then there's no reason for that class to change. So it basically enforces us or tells us go away with those god classes and all. Sometimes when we code, we try to put all our code in a single class and make it a god class which does everything. But that is basically against the single responsibility principles, and that causes lots of bugs and all, because a slight change in anywhere demands a change in that god class, right? So that is a kind of an anti pattern or a wrong way of doing it. So the better way is to divide your class, your big god class, into small classes and modules. And yeah, these solid principles or single responsibility principles can be applied in any while designing any computer system. But in this course, we'll be focusing more on designing classes and functions. But yeah, this principle can be applied on different use cases also. But it states that just try to give you a particular module or class or function just a single responsibility when you are coding or developing it. Now on the right hand side, you can see two images, right? So the first image is of Swiss Army knife, right? So you can see Swiss Army knife can do multiple things. Like it has a Caesar, it has a knife, it has a cutter, it has a screwdriver. So like it is doing lots of things. So in a way, it is, if in future suppose we need we need an opener here also, then basically we will come to this class and we will add the opener here also. Or suppose we want to have a curvy Caesar, right? Then again we have to visit this class to change the logic of Caesar and all. So you can say, you see, like this is acting as a god class, and for any small change we have to just come and change here. So it's basically voiding our single responsibility principle.
Now let's see.
In the below image, right, we can see the knife. The knife is only been used to cut something, cut fruits or so. It's just doing a single thing of cutting thing. So yeah, so we can say that knife is following a single responsibility principle. Similarly, Caesar or a separate Caesar or a separate screwdriver, all those are following a single responsibility principle. And it's good to have that, because they, in future, if something changed, like if we want to have some curvy Caesar and all, then we can have a new pair of curvy Caesars also. So since in this way, this is a concept which has been projected by a single responsibility principle. So yeah, in the next video, we can see some code in action. Now, if you will see this closely, right, banking service closely, right, then you can see banking service is doing lots of things. Like basically, banking service is holding account, and then it is getting the account balance. Now it is withdrawing the money. This thing is, this guy is doing lots of things. And then we are able to withdraw money, and here also is asking account for the balance person, generating the balance. So this, and then it is pinned in the two. So and then it is getting loan interest. So you see this single banking service class is doing, and we can send OTP also. It's doing too many things. Like it is basically doing more than a single thing, and it has multiple reasons to change. Like in future, printing logic data change, and I have to change this, come to this banking service class and change this method. And if in future, if the interest percentage one more, if you're offering one more time what type of loan, or if the existing loan percentage change also, then again I have to come to this banking service class and make these changes. And if in future, suppose I have now sending OTPs to numbers, in future if I have to support sending OTP to emails or WhatsApp and all, then again I have to come to this new method to change here. So basically, this class has multiple reasons to change. I can say this class basically voids single responsibility principle because it's not doing a single thing, and it has more than one reason to change. So now we'll try to refactor the code and try to implement single responsibility principle here to fix things. Yes, so let's see. Let's try to refactor things. So we can start with this print data for passbook, right? So we are using get banking service to do this print in data, right? This is not a job of this banking service. Ideally, it should be handled by some printing service. So we can change this banking service to print service, right? Then basically now it will say me like this, nothing like print service, right? So I can create a local variable print service, and this is not my banking service. I can say this is my print service. So I can simply say, let's just create a print service for now. I can say via print service equals to new print serve. You get a new print service, and I can use that to basically create a class called print service in my coding folder, right? And then this will be here. I can create this method. I can just go to this I can just go to this banking service again. Let's just go to banking service again only, and then from there I can refactor things a bit. I can say just move this method to my printing service. Cut this method from here and place it in my printing service. Now I can have this method here. Looks good to me, but yeah, the printing service also wants an account, right? I can create a local variable, create a field account in printing service, and now I can create a constructor of it, and again initialize the account there. This looks fine to me, so this will go away from here, and I can have my print service handle that. Print service will get the printing passbook, and here it wants the account, so I can pass the account. Print service is getting account, and it is just basically printing the balance using the account. So the responsibilities clearly be removed. The one responsibility for printing service, so it looks fine here. Now let's see how can we move loan interest. So the loan interest is again not a part of banking service, but this we can again create one more service which we can name it as loan service. So I can say this is the new loan service, and I can create this loan service in a separate class. Yeah, we can just create a local variable for a loan service, right? And here we can just move this loan interest method from here to my printing set, my loan service. Right, and now what I can do, I can rename this to get interest percent because it's already a loan service. It's back here. Now I can simply change this to loan service and these to my those methods. So that's the loan interest method. And the last thing, this OTP, right? Well, this OTP also I can create a different service, which is my notification service. You can have a new notification service. Not a notification, I can have a notification service. I can take help of IntelliJ to create a notification class. I can have a notification service here. Get a local variable. This should able to send OTP to mobile. For this, I can create a what? I can create a notification service, and I can use that to achieve that. So again, I can move this send OTP method. I can cut this send OTP method from here. I can cut this send OTP method from here, and I can go back and place this send OTP method in my notification service. And here I can just have this thing. And it wants account again, so I can just create a local variable called account. Just create a field out of that. No, we can create a field of called account, and then I can create a constructor which basically accepts account. This looks fine to me. Now I can go here, I can just pass account here, and then here instead of this, I can have my notification service. So yeah, these things look good to me. Now, if I go back to my banking service, right, for depositing money, it is first asking the balance out of the money from the account and then updating the balance. This looks weird to me. Like a banking service is called in deposit money, but actually the account should be the one which should handle this money related thing, right? Like I'm thinking to move this thing. Basically, the updating the balance part should be the responsibility of account class only. So instead of doing this, what I can say is I can just have one more method here, which would be I can simply say that as would be one method I can say as update balance. And then I can say whatever I can say add money. That seems better. And my money I'm adding my account I can add money, right? So I can simply say add money because I'm actually adding money, right? So and then I can simply say yes, this dot account this dot balance plus equals to and I have whatever amount I'm getting. So I can have a double amount here. Yeah. Then instead of doing this, what I can say here is instead of doing this whole thing, instead of asking the balance, like I'm basically avoiding that principle, like tell don't ask. So I'm asking the balance, right? So I simply have to tell this. I can simply tell the account to do this thing for me. I can say add money and I can simply pass the amount to it. And this account will handle this. Right. The same way for that getting account balance, I can do what? This is fine. I'm simply invoking account to get balance. Now for withdraw money also I can say with money, withdraw money. So again, for this account, this thing also I can go to my account and I can say add money. I can simply say withdraw money because it's a single responsibility, right? One method should do a single thing only. So I can create a separate method and say withdraw money, and I can simply separate the amount, and then I can go back to my all in class, and there instead of asking the balance and then updating it, I can simply do account dot withdraw money, and I can pass the amount to it. I can directly do I can directly do it with account, but banking service is just I have to basically do things via that. So yeah, so in this way I can have simplified my banking service a lot, and I've moved the responsibility of corresponding classes to moved the responsibilities of the classes to separate. Like I have a banking service class, then there's a loan service class, and then there's a notification service class to send notifications to different mobiles, and then there's a print service class. Yeah, hi people. So in this video, we would be discussing about open and close principle. So second letter in the solid O stands for open and close principles. So open and close principle states that according to new requirements, the module should be open for extension, but closed for modification. So in context of classes or modules, like any module should be always open for extension, but at the same time should be closed for modification. So which indirectly means like we should be able to add new functionality to the current modules or classes, but at the same time we should restrict the modification of existing classes or modules. So that is the thing that this open close principle states. The extension allow us to implement new functionality to module. So yeah, we can take the example here. Like suppose we have a vehicle info class, right? And vehicle has a vehicle number, right? And then if the vehicle is an instance of car, then we can get the vehicle number. If the vehicle is an instance of bike, then we can get the vehicle. We have a vehicle class, and we are using a vehicle number method to get the number of a vehicle. So we can have different types of vehicle, right? We can have a vehicle called car. We can have a car as a vehicle. We can have a bike as a vehicle. We can have a in future. So if we have car and bike, as of now, our method looks like if it is an instance of car, then we are using a car object to get a number. If it is an instance of bike, then we're using bike object to get the number. But suppose like in future we need to handle truck also, and then again we will have to add one more if else in this vehicle number class to achieve that. So in a way, we are modifying the existing functionality, like existing vehicle number, or changing any existing method which has already been closed. On contrary to it, we should be able to add something new instead of altering the existing functionality. So how to achieve this with the help of open and close principle is like basically we can have a vehicle info parent class, and then we can have a couple of child classes. Like there would be a car class which is extended vehicle info, which will have a vehicle number method. There would be a truck class which will extend a car class, and it will have number method. So basically we will be using an inheritance to achieve these things. Like instead of actually modifying the existing method, we will create a base class called vehicle, and then we will have different child classes for car, bike, and truck, and we will use the corresponding class to achieve this. And in future, suppose bulldozer comes or suppose train comes, then we can again inherit a vehicle class and then make a separate class called train and handle the methods there accordingly also. So in this way, we can use inheritance to basically implement open and close principle and improve our design. So yeah, next we'll actually apply this open and close principle to a app that we are building from the previous video. Let's see. Yeah. Hi people. So in this video, we would be affecting we would be implementing a requirement, and then we would be affecting our code to basically implement open and close principle. So let's see. So our requirement, like until now we have built this app and we have these tests in place. So now the requirement is like we see the last test, right, where we send an OTP to mobile. So the requirement is while sending OTP to the mobile, they want to send a greeting message also, whatever user's account is, so he can say hi in this, like in this says hi John or so, and then your OTP is this, and then there would be a disclaimer message like please don't share this OTP with anyone. So these things we want to send it. So I can rectify this case and say so able to send OTP to mobile with the custom message or we can say with greetings. Let's first do it for greetings. I can go to this notification service, that OTP method. Like here I can create one more method where I can say it could be my private method. I can simply say or I can simply call my private method again, send greet user. Let's first do greet user, and I can say create a method greet user here, and I can say I can create a string formatter, then that would be more better. Let's see, string formatter. I can say hi, and let's see. I can have here place of name account dot get the name of person. I can simply say name. I know there is no field called name in account, but let's create that now. I can say it will return me a string, and here I can expect to return whatever name is done. What was the name of the account holder? I can simply return name, and then change the message as your number to this. And now let's see how our test will fail because the message has changed, and we will simply copy and paste that message now here. Yeah, so it is failing. Hi John, OTP is sent to your number. I think Greetings, John. Do we send to your number this? Or let's just, instead of greet, I can say, as I will send OTP to mobile when greetings and disclaimer. Let's do it for disclaimer too. That looks more better. Disclaimer. And I can simply go to my this method, send OTP, and there I can have hi John. Greet and disclaimer. Disclaimer. Hi John. I can then have please don't share this OTP with anyone. Right? So I can do this. Now I can go back. Let's see. So don't say this OTP with anyone. Then I can go full stop, and then next line, that thing will come in picture. So let's see how it looks now. It will fail, and let's see how it looks. Yeah. So hi John, please don't say this OTP with anyone. OTP sent to your number. This is cool. Now let's just modify it in a local variable. It's expected. Let's name it as expected only then. And now what I can do is I can say I can use the complete string format to take the string not format, and I can say I can copy this text from here to here and paste this thing here, and I can have this thing here, and here I can say hi, whatever is the name of the account holder. Please don't say this OTP to anyone. OTP sent to your number. This right, and I can have this thing here. After that I can have, and then I need this also. Yeah, fine. And I can here say as account dot name, and the second thing I want to have is account dot mobile number. Right. So yeah, this should be how my test looks. Now I can say I'm expecting this like please don't say this OTP anymore with your number name. This is this, and then I'm simply saying simply calling my exert and seeing how it looks. I can move this thing here. Let's see how this thing will look now. Yeah, so this looks fine. So this much requirement is achievable. Now our requirement is like we want to also send this same OTP to the person's email too, like with the same message. So how to achieve that? Let's see. I can just create one more class. Now the problem is if I have to send this to the WhatsApp also, then I have to change my send OTP implementation. I need to have one more thing. Either based on like I have based on the parameter I have to send to different, or I have to just write logic here. In the actual scenario, we will be using some different libraries, like use some library to send OTP. Now we have to use some library to send email to. So we have to implement all these things in a notification service class. So if we will do that, then in a way we are basically voiding that open and close principle, because we have modified the existing class to add more functionality, and that seems wrong, right? We till this my functionality is fine, like I'm able to send a message, but now to send the message to both, I have to modify this send OTP method to achieve something that does not looks like I have to support email and message SMS. I have to modify this method, and later on, if I have to send OTP to WhatsApp too, then again I have to modify this send OTP method. So this design does not look right. To fix this thing, what we can do is we can implement open and close principle, and we can take the help of inheritance to solve this thing. So what I'm thinking is, let's say it. Let's just comment this method. Let's make a copy of this method, and then let's just comment this method for now. Like we just modify this, and I want to make this send OTP method as an abstract method. Basically, I would be creating child classes which will implement this OTP method. Right, so I have created this as an abstract class, and now what I can do is I can go to my test. My test will fail now. I can change this class to basically SMS notification service, right? You can say SMS notification service. I can take the help of my, and I can just say here bank account, and I have the same method side. This seems fine to me, and yeah, now it is asking me to implement some methods, which I can implement. It looks cool to me, and I have already copied that method, right? Let's see if I have copied. Yeah. So I can just place that here, and I am good to go, right? And load OTP method. So yeah, this came here. Now the problem is it's unable to find this grid and this disclaimer thing, right? So that we can fix. I can make this as protected so that its child classes can access it. Right? Now account is a problem. So account I can create a field, and then here also I can pass that account. Right now, if I go to the test, I'm hoping the test would pass. What's the problem? Okay, it's saying there are two tests with this name. For now, let's comment the second test. And yeah, I can just run this thing. Let's see. Yeah, so but test is passing for SMS notification service. Now we can implement that email notification service. The same way we can do it here. We can simply say, hi, please don't share this OTP with anyone. OTP sent to you. And this one, please OTP sent to your email. Right? And here I will be having my email. You can ask the user email. Okay, so email is also not a public field. Let's just make that. Go to that. Right, in my bank account, I can just now return my. It would be of my return this not email. And email is also a string, so can we not this to string? Right, it looks nice to me. So yeah. And now here instead of notification service, I will be using my which service? Using my email notification service, right? And then I can say this as email note. I can tell you to create this class, have this thing. I can just no, I don't have to delete it. Sorry, ma'am. To this as a field, create this as a field. I have added the account here too. I can implement the unimplemented methods. Fine. Now we will see. Let's first complete our test. Okay, so able to send OTP to email with details and disclaimer. That looks nice to me. Let's just send this test. It will fail for now, but okay, we are getting null. That's fine. That's cool. Now let's go to the notification service and see how we can achieve this thing. Okay, I can delete this. Then I can go to this. I have to go to email notification child class, and here I can simply say, oh, let's just do it in this only. Remove public from now and have this. And I can OTP sent to your email, and here I can pass the email, right? Now let's see whether it is passing or not. Cool. So basically my test is passing. So in this way we can implement our open and close principle. Let's just run all the tests for once and we are good for now. Cool. Yeah, hi people. So in this video we will be talking about Liskov Substitution Principle. The L letter in the solid acronym stands for Liskov Substitution Principle, and it was introduced or given by Barbara Liskov. She was a computer scientist, and it states that it applies to inheritance in such a way that derived classes must be completely substitutable for their base classes. In other words, if a class A is a subtype of class B, then we should be able to replace B with A without interrupting the behavior of the program. So this statement basically means that suppose we are currently using class A, which is our superclass everywhere in the method, everywhere in our code, and we are calling methods on class A and all, or A and all. And now there's a class B, which is basically inheriting class A, right? So it states that we should be able to interchange wherever we are using class A object with class B object. So in a way, whichever methods we were calling previously on class A will now be called on class B. So the thing is, now since it is inheriting that class, it will ideally get all the methods that are present in class A. But there might be some methods which are not being implemented, or there's just a skeleton code or a declaration of that function in the class, but there's no logic in that. They're throwing some error inside that or something. So if that should not be the case, but Liskov substitution principle states that all child classes should inherit those classes where the methods they are getting are meant for them, are usable by them. Basically, they should have some body with them. Like when they are running their superclass method, when the child class is running the superclass method, then it should be executable and it should give some meaning to them. If they are not giving any meaning, or if they're throwing some error or so, then basically we are avoiding the Liskov substitution principle. In the second line, it extends the open close principle and also focuses on the behavior of superclass and its subtypes. We should design the classes to preserve the property unless we have a strong reason to do otherwise. Okay. So now let's see an example, a classical example for this is this thing. So we have a rectangle class, right? In the rectangle class, we have a method called setWidth, which we are using to set the width of a rectangle, and the same is there is a method for setHeight, which we are using to set the height of a rectangle, and then there is the area method, which is simply multiplying these two and returning us the area. So till this seems fine. This is our superclass rectangle. Now we create a giant class square, which is basically extending rectangle. And now since we know square has 4 sides, but for them 4 sides are equal. So basically height and width are equal for square, right? So every time we set a width, what we are doing is we are updating it in both the width and height object, like width and height of a super, like we are using super.set width and super.set height, right? So it will go here and basically update the width and height both when we are setting the width. And same is the case of height. And height also we are updating both height and width of the square using that super method of rectangle. So this seems fine. So here you see there's something wrong. Like just to fit in the square as a rectangle, we are basically have to update a call our two method twice. So first of all, this looks bad on the design side. And now if the consumer is using it in this way, where they're saying like suppose for a rectangle, to this will work, they're setting this width as 5 and the height is 5, and when they're getting the area, it will be 20, it looks like. But when they're doing it for square, when we set 5, then it will make both the width and height 5, and when we make height 4, then it will make both width and height 4. So at last the width and height would be 4 only. So when we will print area, it will no longer be 20, it will be 16. So this will void our whole design, and this is basically voiding our Liskov substitution principle, which states that we should be a subclass should be placed a parent class, subclass object should be can be substituted. The parent can substitute the parent class object, so that is not possible here. So to fix this thing, the ideal way is not to inherit those classes which are not may not have correlated methods. So if we want to inherit, then here the better way would be that we might have created a shape class, and then both rectangle and square can inherit that shape class, and whatever common methods or common functionalities are there, then can only move to shape class. So in this way, we can implement the Liskov substitution principle here. Yeah, hi people. So in this video, we would be implementing Liskov substitution principle to improve our current design. So yeah, let's get started. So we got additional requirement, right? Like our bank should support fixed deposit account, right? That is a new requirement that we got. So now in our account world, we can have two kinds of account. One is our basic bank account and other is our fixed deposit account, right? Now let's say like I'm able to deposit money, right? Now I'm saying I should be able to deposit money to a fixed deposit account. So I can just create a new test, which looks fine to me. And I can here say I can create a new banking service, since banking service is directly coupled to account. Like for FD, generally we create a new account number, and under the new account we try to do things like, so I can say banking service. I can name it as fixed deposit banking service, right? And now, yeah, I can make it pass as banking service dot. I can simply name it as fix. I can simply say here, and this time instead of bank account, pass a fixed deposit account. Right? I am passing the fixed deposit account here. Let's see now what happens. There is a typo. Let's start a typo. Now take the help of IntelliJ to create this class. This will go in my coding folder. I have a fixed deposit account, right? Looks good to me. All things have been passed to the parent one. That looks cool. Now, if all the methods are implemented in parent, but the thing is, I cannot withdraw. The thing is, I cannot withdraw the balance in the fixed deposit account, right? So if I will try to, let's see, so if I can say override methods, and I can override this method and withdraw money. Like I can simply say, cannot withdraw money. This looks weird, right? Like if I cannot withdraw money, and then why it's just withdraw money method present in my bank account, not withdraw money, right? So this looks wrong, right? Like in fixed deposit, what actually you can do is, like if you want to take out the amount, and then you have to break your fixed deposit, and then only you can take out the money. So you cannot directly withdraw money. So let's just see our test, right? Account balance is there, and this is able to deposit money. Like this, able to deposit money to fixed deposit, which is correct. I can deposit money to fixed deposit, which seems correct to me. I can simply pass this. For now, simplicity's sake, I can just copy and paste these things from there to here. And this is a fixed deposit account, right? So let's just create a variable out of that, and I can name it as, and say FD account, fixed deposit account. We're able to deposit money to fixed deposit. That is fine. I'm able to deposit it. I can deposit money of how much? I can deposit money of, again. So I can deposit suppose 40,000 or suppose 25,000 in my fixed deposit. Fine. This looks good to me, and then I can simply get the balance, and I can say 25,000. Now this will work, and I would be happy with this. Let's first test like we are able to deposit money to fixed deposit. We are able to deposit money to fixed deposit. We are good with that. Now the challenge will come when we will try to withdraw money from the fixed deposit. Because we should not be able to withdraw money. Not be able to withdraw money from fixed deposit. So here I can use that fixed deposit banking service, and if I do this, I think this would work. Like it was 25k before it, I added 25k in my fixed deposit, right? So let's name it as variables only, right? Fixed deposit investment, right? And I can make this also something like deposited amount, right? This looks fine to me. I have made these things as well, and here I can simply say it's the save and deposit amount, and here I can say it is the deposited amount. Trying to withdraw money, but the money will still be remain same. This will pass because I think we are overriding the money method inside the banking service class. No, but the thing is, if I go to account withdraw money, right, then in that child we are not withdrawing money. We cannot withdraw. This is passed, but the design is not right. Like I'm getting printing this cannot withdraw money, or if I can throw exception here also. All these things are not right. If you see, right, this is breaking our pencil like it is time banking. Visible amount is basically having a method which is not being used inside that. So this basically voids our Liskov substitution principle, like the subclass is not substitutable to the parent bank account class. I can go to my bank account and I can delete this withdraw money method from there. And then what I can do is I can create one new type of account that is my saving account. And this should extend my banking account. Saving account, I can have that withdraw money method. I can just copy this and have this. Or I can simply take the help of setters and getters and do this in like set balance, and I can say it's this dot get balance minus amount. Let's see now the things are ending or not. First of all, this field, a banking service, there's no withdraw money. And this banking service is also calling a method which is not present on the saving account, bank account, right? So this will fail. So how to fix this is, again, we can do, instead of using banking service here now, I can create one more service, banking service with withdrawal support, or one other way is I can simply have a separate service called withdrawal service that will be doing this thing for us. So I can instead create here one service which would be my withdrawal service, and here I have a constructor which is basically having saving account instead of banking account. Now I just have to create an input piece field for this, and here inside here I can have that same method, same particular method, which is whatever method that we saw in banking service, right? We can use that method. You can just cut this method out of this because banking service does not have no longer have that withdrawal feature, or that we have a withdrawal service. And then here I can have this, and here you can name this as saving account. Withdraw money, and now for example fixed deposit, my fixed deposit is filling. There is no need to override it because bank account does not have the withdraw money method anymore. Like if I go inside this size, there's no withdraw money method for now. Now I can delete this commented code also because withdraw account thing is only being accessible in the child, which is the saving account of the bank account class. Right? Now what else? Withdrawal service looks fine to me. Banking service looks fine to me. Now let's just go to test and fix things if we can fix something. Child banking. So you see, it's saying like there's nothing present in the banking service now. How can I do this thing? So here I can take, like as of now, creating a new object will be a bit tricky. So what we can do is, so basically we can make withdrawal service extend our banking service, and then we can pass the saving account that we're getting as a parameter to the parent one. So since saving account is also a type of banking account, like saving account class inherits and banking account, so basically our super constructor will banking service constructor will be able to accept a saving account because it's also of type banking account. This works, and then we can withdraw money. And now let's go back to our test and try to change it to make it work. So here, what I can do is I can rename this withdrawal banking. I can rename this to banking withdrawal service and withdrawal service. And what I can do is where I'm creating the object of this side, there, this is of banking service type, that is fine. I can change the type of this to, I think, that's saving withdrawal service site, make it as withdrawal service. And I can rename this withdrawal service again to withdrawal banking service because it is doing withdrawal plus banking service both, right? So better to name it that. And here I can name fix this typo. I can say withdrawal banking service, and yeah. Now here it is creating the object of banking service, which is wrong, right? So how now here I can say create the object of which service? I can create the object of simply withdrawal banking service. Like the normal banking service can only deposit money and give the account balance, but the withdrawal banking service can even deposit money, can even do whatever banking service can do, and can also withdraw money. Here it needs a savings bank account, so I can change this to a saving bank account. Should I change this to a saving bank account? Then what happens? Yeah, everything seems to get working. Just that. Okay, like I cannot withdraw money, so basically this method will not work, which is correct. I cannot, as we cannot withdraw money. Withdraw money, fixed deposit. So this is correct. You can comment this code. All the test seems to be fine. Now let's just run the thing and see whether we are able to achieve all test step pathing. All test step pathing, and in this way we can use that Liskov Substitution Principle to basically substitute out all those things which are not being used by our child class. First of all, our FD account was not having the withdraw mechanism, so we excluded that, and just our saving account is having that mechanism. This was a saving account, right? To rename this to a saving account, and this was only having that mechanism to basically withdraw money, right? So that can be done here. And then withdrawal banking service, like a normal banking service, can simply deposit money and get the account balance, but the withdrawal banking service to bank balance out of the saving account. So in this way, we can use Liskov Substitution Principle to achieve the desired design. Interface Segregation Principle. So the I letter in SOLID stands for Interface Segregation Principle. This principle states that a larger interface should be split into smaller ones because the implementation classes use only the methods that are required. We should not force the clients to use the methods that they don't want to use. So basically, if the class is implementing a very big interface and there's some methods which that class or those group of classes will not be using, then it's better to segregate out into a separate interface. And those classes which are using that methods will implement a small interface, and others will not implement it. So it's that this principle basically enforces us to make granular interface, and classes can only implement those interfaces for which the methods they are implementing. No class will implement an interface which has methods it will never implement. So that is the main goal of interface segregation principle. The goal of interface segregation principle is similar to the single responsibility principle. So yeah, we can see the example for that. So let's suppose we have a conversion interface by which we can convert into double, we can convert into convert character to string, right? Now convert into double interface. So this big interface, which is having three different methods to convert into double, into and character string, can be divided into three separate interfaces. Where first interface will just have a method to convert integer to double. Second will just have for integer to character, and third will just have for convert character to string. So suppose we have created an interface named conversion having three methods, into double, into character, and then we can have three methods. If we want to use only a method into car, so suppose our child class is just using the method into car, then it can just override, implement the interface into car, and we have no choice to implement a single method to overcome this problem. The principle allows us to split the interface into three separate ones. Yeah, that's what we can only now we can use the method required. Suppose we want to convert integer to double and character to string, then suppose any class wants to use just this convert character to string and convert integer to double, and it can just implement first and last interface. So in this way, they can choose whatever interface they want. So yeah, so basically that is a goal of interface and segregation principle, is to segregate interfaces into smaller interfaces, and those classes should only implement the interface for which all the methods they are using or about to use. So yeah, that is pretty much interface segregation principle. Yeah, hi people. So in this video, we would be trying to implement a requirement, and then we will use that interface segregation principle to basically improve the design of the requirement or solve the major pitfalls in that. So yeah, let's get started. So now the current requirement is our bank wants to support UPI payment, right? So as of now, they've just started with they just want to start UPI payment for their customer as early as possible, and they don't have any infrastructure to build their in-home UPI. So they thought of going with the Google Pay, try to make payment via that, and later on they will think of using their own payment or introducing other payment gateways also. Let's start. So I can say I can create a new test, and I can say it should be able to make payment via UPI payments via Google Pay. So we can write should be able to made payment via UPI using Google Pay. Okay, and now what we can do is I'm thinking of creating since I'm initially planning to use Google Pay, and in future I want to build my in-house UPI payment system, and also use Paytm to make UPI payments. So why not let's create some skeleton in place which will use to make payments. So by skeleton I mean let's create an interface and then define certain methods that we'll be doing while we make a UPI payments also. So I can create an interface named that is my UPI payments interface using Google Pay UPI, and I can say new UPI payment via Google Pay. And now let's just go and delete this. Let's see interface and classes. I can say UPI payments. Yeah, so I can create a UPI payment interface, and here I can have some abstract methods. Like first method could be pay money. Let's name it as pay money. It's for now just a pay money method. I can simply make a return string, like I'm not actually implementing the whole payment system for this, for the sake of this tutorial, and just return in the screen like the payment has been made to this. What else UPI payment system does? Like if I'm building, as of now I'm using Google Pay. So for Google Pay, I can say like we can pay money and then we get sometimes when we pay, we sometimes almost every time we get a scratch card when we pay money, right? So we can say we can have a method which can give us the scratch card. Also, when we pay, and again return string, let's to simply return me a string. And yeah, like a more feature which I've seen is like we get some cash back as a current balance, right? Like we sometimes when we pay, we get some cash back via Google Pay or so. Initially, we used to get lots of cash back. Now it's not that much, but yeah, we get cash back when we make a UPI payment sometimes. So you can have method called get cash back as credit balance. And again, I can say here, right? Simply return a string. Yeah, so this could be my interface of UPI payments. Now let's go back to our test. Now let's take a help of this to create a Google Play class. And yeah, I can again, for simplicity, I can pass a normal saving account to it. Like generally our Google Pay payments are tied up with our saving account side. So I can attach account to this and I can say, just create a class of UPI payment via Google Pay. I can have this thing. I can, make it implement saving account, which is fine. Right. And here, like UPI payment happens only on saving account, not on FD account. So this is fine. I can have saving account only. And then here I can create in a field, global field for this. And yeah, I can first implement the interface method, right? So I have a pay money method, get scratch card method, and get cashback as a credit balance. So I'm assuming whenever I make a payment, right, I will be getting a scratch card and I would be getting a cashback as a credit balance. So let's just write our test keeping this thing in mind. So I'm saying this is my saving account, and whenever I make a saving payment, right, I should get an expected thing. So let's first make a payment from example Google Pay UPI. I can say pay money and how much money we have to pay. I can pass a parameter here too. I can say how much money I have to pay. Suppose I paid 300 or 400 bucks, right? Pay money this thing, and basically this will actually return me a string payment. Or you can also pass a sender UPI ID, which can be anything. I can say bond, and that would be my UPI ID of the person I'm sending money. So bond and that UPI dot his bank name, right? Bank name. I can have UPI bank, and yeah, I'm paying money to this guy. And now what I'm expecting in return. Let's just build that. I don't need this much long string. I can simply say this money has been paid to UPI ID this, right? And then I can say in the next line after this I can say have received a scratch card, and have one more thing. I have received whatever is the paid amount, right? So I can say for that I can say whatever is the paid amount I would be receiving 1% as a cashback, right? For now I'm as of now I'm using a new service, so I can give lots of cashback. Later on I will be even 0.0001 of cashback, but for now it's finite. I have received a scratch card, and I have received this much of cashback. This could be my double cashback. Let's just add these things. So I can first create this thing as a variable and name it as paid amount. And it has been paid. So the first thing that I am doing here is my paid amount, this much paid amount. Okay, I can move this thing above, right? And I can here say paid amount, right? And now I can just extract this thing, which is my receiver's UPI ID. Okay, receiver's UPI is fine. This also I can move on my top. How much top I have gone? No. Let's just go one level top. Why? Yeah, cool. Now I can simply have the receiver UPI, or if it is not doing manually, I can go here and I can simply add receivers. I can simply say string receivers UPI ID, UPI. More here, receiver UPI. So I am saying paid amount has been paid to UPI ID. This sentence is simply have received a sketch pad. This I can keep as constant in that method. And then at last line have received this much cashback. So cashback I can say would be that much percentage, right? So I can say it's 0.1% percentage of the actual amount. So I can say paid amount into 0.1, right? This would be my cashback received. Now let's try and see what is the output I'm getting. Okay, and test fail. First of all, it's saying util format mismatch exception. Let's see what is a mismatch here. Amount has been passed. I ran in this test only, right? It's failing at which line? It's failing at this line, right? Format mismatch. Okay, I have received. Okay, so this is wrong, right? I can say float. Will float work here? Okay, the first thing. Okay, the first thing is paid amount. Right? Amount can be again double. Has been passed failed to has been paid to the UPI ID, which is string, and paid how much amount? This much. Let's see now. Yeah, so test actually failed, but there's no compile time I test. So if you can see here, we're seeing it 400 has been paid to UPI ID this and have received a certain I received a cashback and I received this 4 as a cashback, which is fine. It's cool. And I can now go to pay money. I can just go to its implementation, and now here I can add my magic. I can say first of all I can add my this current scene. I can say again let's create a formatter here only string. I can say paid statement, or I can simply name it a statement, right? And I can use the string formatter now. I can say format, and yeah, I can just copy and paste this huge guy from there to here, and I will be adding stuff to this. I can again start the software app here. Let me just wrap the stuff here too, so that I can get everything in my single screen. You can say here, so here my percentage amount will come, which I will see has been paid to UPI ID. This much is only required, as all other guys will give me the stuff has been paid to UPI ID. This, so I can just have this percentage as here. Now, first of all, I need how much amount. Amount I am also getting as a parameter and has been paid to which receiver UPI ID. This receiver. In the real world, we will actually be having a implementation, some API, which will be actually making a payment, some Google API basically to make a Google API payment. But for the sake of this tutorial, I'm just returning a string. This is fine. I can name it as paid statement. I can get other statements. Let's again return string here. I am good thinking in a more clean way. So let's just we'll have 3 separate statements for first of this, and each would be separated by space, right? And the first statement is this paid statement, which is looks cool to us. The second statement is you will be getting sketch card. Voila. So I can say this dot get sketch card, and at last I can earn the sketch. At last I can earn what I can say get cash back. That cash back as a credit balance. Right? Yeah, so I can return now. I have my paid statement, get sketch card, and the other thing could be my cashback. And for cashback, I think I need amount too. I can say this dot get cashback as credit balance, and in this I can pass my amount. I can make it expect change the signature of this. In this I can simply say amount into. For now I'm hard coding it. Why? Let me make it as a pivot field. I can make it as 0.018. I can make it 0.01, and I can make it here. I can simply again I can use string formatter, and I can say alternative is a cashback field. Okay, and now at last I can simply return scratch card. This not cashback field. Right, fine. Let's go back. I can go to my bank app test. There I can simply end my test, and let's see if I'm getting anything to do. And the test is not passing. Let's see what is the problem. Because this is still this is fine, but one thing have received scratch card is missing. So that thing I can add in my pay money. I can go to implementation of scratch card, which is here. Here I can simply return have received a scratch card. Yeah, it failed, and I think now the problem would be the decimal places only. Yeah, so I can just have a decimal places formatter. Format it. So to format it, I can simply use, I think, that I can simply use that point. I can specify how much decimal places I have to do. I can say 0.2f whatever. So I want to do it for 2 decimal places only. This would be fine here. Same, I can do it for here too. And now inside the pay money also, if I have not defined anywhere, then I can do it in this way. Pay money days now here on the cashback percent, I can simply do not 2f like 2 decimal float places. Now if I end test, I'm hoping this time this should pass. Let's see. No, it still failed. And now what's the problem? Okay, my bad, because this is not anything. Okay, still some problem is there. Okay, so expected. I think here also for amount paid also we need to have it for 0.2 decimal places. Let's see. If we get cool. Now all of things are formatted correctly and we got the head design. So till this we are able to make payment via Google Pay. Now we have built our own UPI payment system, and now we want to also use that too. So what we can do is we can simply take the reference of the same interface, and we can have to able to pay via in-house UPI payment. This class will implement this, and I can create a class of this name in my coding folder. Can have in-house payment, saving account. Okay, so now the problem is they are giving option to pay money. Our in-house payment, we are supporting option to pay money, which is fine, but we're not giving systems to have a scratch card. Scratch card is not supported, so I can say no scratch card, and we may return some credit card balance if we want, and again the percentage could be different, but we may return. Think is this scratch card is no longer required by us if we are building our in-house payment, like we are just supporting system to pay money and all. So since we are implementing this interface, that's why we have to implement this interface. I have to implement this method. Keeping a method that we implemented and we are no longer using it. So this appears to be the violation of interface segregation principle. So we have to design our interface in a way which have methods which are in which all the methods we are implementing are being used by that particular class. So we can apply our interface segregation principles, and it states that we can basically separate out our big interface, our interface with multiple methods into different interfaces with that particular method. So I can create one more interface for this, and I can name it as, like, I can go to this UPI payments and I can rename this interface to what I can simply have it as get. I can move this method to a different interface. For lack of better names, I can simply name it a sketch card. And it will just have these methods, right? It's a name example, but yeah, when we add one more UPI payment method, then it will make more sense. So I have a sketch card method. I can delete the sketch card method from here, which looks cool to me. And then here, since I'm doing internal payments only, so this will not have much impact. Like I can go to that particular class. I can just make it implement one interface, which is, since we can implement multiple interfaces in Java, so the sketch card will be fine, and we are good till here now. Go to my project. This works, and this my UPI payments will be just implementing that UPI payments, and then there is a sketch card interface, which is having just a sketch card method. The UPI payment interface is just having these pay money and get cash back as a credit balance method. So this will work here, and I can have one more test. I can make an in-house payment, so I can just remove this thing from there, and let's see whether it works or not. Okay, so it's it's saying I'm overriding the sketch card method, but there's no sketch card. That's why. That's good. I can delete this. I can just copy and paste those methods, other corresponding methods from my UPI payments of Google Play class. I can go back to my class in-house payments. I can just place those methods which I have overridden it. This cashback percent can be created as a field. It's fine, and then I can just increase since I'm using an in-house thing, right? So I can give a bit more cashback here. So I can give it as 5%. I am a very good guy. I can give 5%. Now what's the problem? It's saying override. Let's just go to that line, and it's saying UPI payments is not inheriting. Let's see. I'm doing the pay money thing, right? So what's the problem? Yeah, pay money everything. Okay, so this method is not required. Pay money method is required. So I can simply delete this. I can copy the pay money method from there, which is this. Can have the complete same logic, that same logic here also. And where is my that class, in-house payment class? I can place that in-house method, and we are good to go. Saving can be created. Saving account can again be a field. Make this field with same name, and then pay money. I can remove this pay money method because only once it is required. I can just end this, and let's see. So this will fill because there's no sketch card method, so that's fine. We can delete this. No longer need this. I can remove it from here too, and then I can end it. Let's see if it passes or not. It's not passing because our cashback has increased, right? So I can simply update my requirement of test. Now I am asking the cashback. This looks fine to me, right? And then at last, I am also supporting Paytm. Now, after another 1 or 2 months, there is a lot of demand from the Paytm customers. So I have started supporting UPI via Paytm too. So I can add, like, Paytm is another company which gives UPI payments. So I'm now using that. Yeah. I can say in-house paid earned by Paytm. Okay. So the catch in the Paytm is Paytm, the version with which we are using Paytm or I'm making like it's not not a referring to real company. We're just making the company for our use case. So we're saying the version we are using for the Paytm is not, it's just supporting the feature to pay the things. We don't support cashback also. We don't support scratch card. So now there's another problem. Like if we will try to use the interface, let's just create this class first, UPI via Paytm. I can create this class in my source code folder. Now there I just have the account. Fine. Let's just implement methods. Now the problem is we are also not supporting cashback here. So if that's the case, then what we can do is we can delete this method. But again, we are implementing the UPI payment side, but we are not supporting the method. So that means again there's opportunity to segregate this method into a separate interface and you implement that, right? So let's just create a new interface. I can copy this method, we'll paste there. I can have a new interface. Let me just create a new class from here, new interface from here, the interface, and it will be named as cashback interface. Here I can make that implement just that method that I want, which is that cashback one. I can delete the cashback method from here. Just think in my cashback interface. Let's just name all the interfaces with API payments interface so that it is easy to understand which is interface. So this is the API payment interface. I can refactor all. Okay. Name this as catch card interface. I'm just making code more readable by naming it accordingly. And then now what's the problem? Where's my Paytm class? UPI payment via Google Pay is fine. Payment via Paytm interface. Via Paytm. I can rename this class, right? UPI payment via Paytm. No need to have interface here, right? It's not an interface. No, the pay money method I can copy it from here only. Although I might have created abstract class also, but this is fine. As of now, we are trying to implement interface segregation principle. So we can go to our Paytm interface. In the method in the interface, so we can have that. It looks good to me. We can create this as a field. Yeah, we have it as a field. Now it looks nice to us. We no longer are using these two methods, so no need to print them. I can just have a paid statement and I can just delete this too. Voila, I have this tag. Let's go back to my task. Let's just update the task and if you're able to pay me to able to make payments. You can simply have has been able to pay UPI and we are not receiving any kind of cashback. So just delete my cashback. And we also don't need receive a UPI here to be needed, but receive cashback like receive a UPI do I need it? I have printing it. I don't need this paid amount because I'm not no longer returning any cashback. Now let's see if I am getting the right value now. Is my test passing? Okay, let's wait. Okay, so our code is failing. There's some compile time and I know what is an error. It's saying like we are overriding this method cashback at credit balance, but this is nowhere present in my interface, which it is implemented. Like it is neither present in this interface, get override, and neither in this interface. Which means if we are overriding this method, then I have to implement one more interface that we have created. It was cashback interface. So I can have cashback interface here, and then when I can end at last, and ideally it should pass now. Compile time as okay. There's still someone issue. Let's see what is this. Why it is not overriding that? Let's see. Okay, so we have also have this in-house payment class, right? This is also using this cashback credit balance like we have done it for our Google Pay interface. It's a UPI payment via Google Pay. This interface confusing me. Google Pay UPI payment via Google Pay. So I can just rename it as UPI payment via Google Pay, and then UPI payment interface. This is fine. UPI you can have in-house UPI payment. So I can rename this to in-house UPI payment. No need to have interface. Right? These are not interfaces. In-house UPI payment, and then the third one was my UPI payment via Google Pay, in-house UPI payment, and one was UPI via Paytm. So this much looks fine to me. Or UPI, let's rename this same as Paytm so I can have it as UPI via Google Pay. Right? Yeah, now these last look fine to me, but the problem is still there's a compile time in my which class? In my in-house Paytm payment class, because we are expecting it to have over this get cashback as credit balance button, but it is nowhere present in my UPI payment interface class, right? So to make this work, I have to implement the cashback interface that I have. And I have implement the cashback interface, and now if I run idly, I'm hoping that the compile time I should go away. And let's see, the test also pass. Yeah, voila. So basically our test is also working. So in this way, by segregating our single chunk of interface, this UPI interface into three separate interface, one was this cash card interface and other was the cashback interface. We were able to achieve we were able to implement this interface segregation principle and basically able to improve and simplify our design using that. That is pretty much in this video. We can just run all the tests to see whether everything is running fine, and voila, all the tests are running fine. Cool. Yeah, hi people. So in this video, we will be talking about dependency inversion principle. Like the last letter in the solid acronym stands for dependency inversion principle. This principle states that we must use abstraction, basically abstract classes and interface instead of concrete implementation. High level modules should not depend on a low level module, but should depend on abstraction, because abstraction does not depend on detail, but the detail depends on abstraction. It decouples the software. So basically, it's saying that high level classes should depend upon abstraction instead of directly depending on low level classes. So basically, in a way, it's saying that if a class should depend upon interface instead of depending on the actual class implementation. Like if they are depending, like if they are composing any other child class inside it, right? And instead of composing the child class, they should depend on an interface of that class, and should use that call the methods on that interface instead of directly calling the methods on the class. So basically it should depend on interface, and then the class that is used, it's been depending on is implementing that interface, so directly it will have that methods. So in a way, it tries us to avoid depending on concrete implementation instead of skeleton code, instead of skeleton and abstraction. So this way it allows us to basically decouple our code in a more cleaner way or so. For example, we can take an example of a Windows machine class. And now suppose machine can be used with a keyboard or a mouse, right? So basically we can say window machine depends upon keyboard and monitor, both side keyboard and monitor, right? We're just taking the written object of both inside the window machine constructor, right? But the problem with this approach is, like, since we are creating it inside that, basically we have made them tightly coupled. It's hard to test a file without machine. So anytime we have to test a window machine file, we have to create the instance of monitor and keyboard first, and then only we can test the file. And in future, suppose we change any method on the monitor or so. So basically we have to change the implementation here to, like, since if we are calling it via monitor, right? Monitor dot method name, then method name might change also. So in this way, this appears to be tightly coupled. So this design looks not and like we are tightly depending on this monitor and keyboard object, right? Instead, these are our low level class and Windows machine is our high level class. So the better way to do is, instead of directly creating the object of this monitor or keyboard class, we can create an interface of keyboard and this monitor class, and then we can just pass the interface object of that as a parameter to this, and then we can create our own keyboard classes. Like we can have a Logitech keyboard class which will implement this keyboard interface and will have the corresponding methods required by this window machine also. So in this way, we are not directly depending on the Logitech keyboard, and instead we are depending on the keyboard interface. And same is the case of monitor also. We can have a VSonic monitor class which is implementing this monitor interface and having all the corresponding methods. This way it improves our design and it helps us to achieve a loosely coupled design. So in this way, we can apply this principle to have a better loosely coupled design. On diagram here can denote be like high level classes there, which is depending on interface, and then the low level classes can just implement the interface when we are building those classes. So in this way, we can use this principle when it is required to improve our design. Yeah, hi people. So in this video, we would be improving our design using dependency injection principle. Okay, so let's get started. And our current requirement is, like, we as a bank, like our bank supports both debit card and credit card, so we should be able to withdraw money from the bank using debit card also. So yeah, let's just start by trying to withdraw money via debit card. I can create a new test and say so able to withdraw money from ATM via debit card, right? I can use for this, let's see what I can do here. I think use any service, or let's say use banking service. If let us say for a site banking service already has an account, so I can say banking service, and I can say dot withdraw from ATM, and I can simply say, yeah, I can pass that debit card object I have. I can pass a debit card object, or let's create a ATM service for this. I can have a new service. I can name it as bank ATM service. So let's just have a new bank ATM service for this ATM service. And what I can do here, I can simply say, take the help of IntelliJ to this class bank ATM service. It would be in my coding folder. I can create this bank ATM service. It looks fine to me. I can create a local variable for this. ATM service, and now I want to withdraw money using it. Withdraw money. Now, if I'm drawing money, I need to pass the spent it ATM service needs a card, like an ATM needs a card to arrive. So I can pass a debit card in this and we'll be using that to withdraw money. I can set new debit card and I can just pass the create a debit class in my coding folder, right? And then let's just make this create a concept of a debit card. I can go back and here I can come to withdraw money. I can just create withdraw money method and here let it accept the amount. I can say suppose I want to withdraw 2000 rupees, 2000, then I can simply pass it and I can then create integer method there. Better was double, but fine. I can make it as 2000.0. I can just take double and yeah, we are good for this. And I may want to withdraw money. And then in the return, I should get the message like, what is the purpose of this test? I can simply say, let's just, for the purpose of text, I can assume it is returning me a string, which is telling me like I've withdrawn this much money. So I'll say, I can just make it as a variable and say with the amount. And here I can say expected is here. I can have one more bracket here and I can say I can use string formatter here and say string dot format. I can name it as withdrawn this much amount from bank, not this much amount withdrawn, amount from bank. Just a simple statement is fine. And now let's pass the amount here. What is the problem now? Okay, let's first create as a separate variable. I can say expected message. Here, what is the problem? And yeah, okay, so the problem is bank ATM service dot withdraw money and say pass withdraw amount. Now the problem is this guy is not returning me anything, right? I can go in this, I can make it return string, right? And this is my amount. Right, withdraw money, this is my amount. And what I can simply do is I can say debit card dot yeah. Okay, so I have to create a debit card as an internal field. Let's take the help of IntelliJ again. This is an internal field. I can say this dot debit card, withdraw money, and say make transaction like I'm just doing a transaction on debit card to get the money out. Or withdraw money. Let's just have the same method there. I can say withdraw transaction. Anything is fine withdraw transaction. And here I can pass. Or let's make a transaction on. Make transaction. We can use the same method to pay some. So that's also, so I can say make transaction, and here I can pass the amount and whatever transaction it makes. If the transaction is successful, then basically, oh yeah, for simplicity's sake, let's just do now this. I can say withdraw money because I'm actually while withdrawing money, there are some charges if I'm using credit card or some cards, right? So better to have a separate method for withdraw money. I can say withdraw money and I can pass the amount and I can simply return that whatever string I'm getting from there. I can create a method for withdraw money in my debit class. I can just fix this typo and I can say withdraw money. And yeah, let's for now have just an empty string. We'll see what we have to do with this. Let's go back. Let's end the test and let's just fix the typo. Meanwhile, let us just end it. Okay. So yeah, so basically we are getting this withdrawn to the bank, but actually we're getting nothing, right? So I can just reuse this messaging and we'll return this corresponding method for my withdraw money method in the debit card. I can say withdraw money. And here I can name it as withdraw amount. Let's name it as withdraw amount. Yeah. And here I can place double amount and whatever amount and for the simplicity's sake, I'm not testing whether the amount is present in a bank account or not. I'm just returning it whatever amount I'm getting. So I can say simply amount, whatever amount I'm getting, and I can simply return that. I can delete this and now let's run and see whether my test is passing or not. Yeah, so my test passed. I'm able to withdraw the amount, which looks fine. Okay, this checks pass. Now the second requirement is to be able to use withdraw money via credit card also. Withdraw money from able to withdraw money from ATM by debit card too. So when we withdraw money for credit card, generally credit card company charges some extra fine or you can say extra charges to basically withdraw. Use credit card to withdraw money from ATMs. Generally, some banks charge 500 or 200 or say $300. So yeah, we will add that too now. Okay, so now the problem is I would be using credit card here, right? But the problem is our bank ATM service expects a debit card, right? So this is the problem. So here you see we are basically, you see credit card bank ATM service is tightly coupled with debit card, right? So this is wrong as per dependency inversion principle, where we say that like a high level class bank ATM service should depend upon abstraction. So not directly depend on low level class, should only depend on abstraction, and basically this low level class should implement abstraction to get those corresponding methods also. So to correct this with the help of dependency inversion principle, I can change this to an interface which would be my abstraction here, and I can name it as bank card, and then I can just, let's first take the help of IntelliJ to create a bank card. I can name it as bank card interface because this would be my interface. So I can have bank card interface, and I can name it as bank card, and let's have this as I bank card. Like it's an interface. In some languages we add I for interface. I can say I bank card, and there I can basically have this method. Which method? That is this withdraw amount method. I can have that. Okay, my bad. Where am I? I can go to this iBank card, and I can here simply have with the amount, and I can simply specify it as string, and plug in it on me as string. Since it's an interface, so I don't only need a signature here. I have my signature, and this is bank card, and then here also let's rename this as bank card only, because I generally use in .NET and all. We are coding in Java, so naming it bank card is fine. And I can rename this to bank card because this class will only depend. This high level class will only depend on abstraction. So spam, it's an abstraction. I can just continue where there is some problem that we will see. Now it's not a debit card. I can make it as a bank card. Wait, and I can then rename this to bank card only. And then what? I can delete this, and here I can pass a double amount. Okay, so problem is the amount that we are passing in bank card, it should be of amount is of double type, right? So I can make this double. Now it looks fine to me. Now let's go to the pane and fix the things. First of all, debit card is different than the bank card, right? So somehow we have to tell like the debit card object is low level class is basically implementing the abstraction on which this high level class bank ATM service is dependent. So for that, what you can do is you can take help of IntelliJ and just have, okay, so we have a debit card class. What's the problem? Okay, I think I have altered debit class. That's right. Bank card is already there, but this is not a debit card. IntelliJ did something wrong for us. It is still a debit card class, but now here we can say it's still a debit card class, but now it should implement that interface. So I can say make debit card, implement the bank card interface. Yeah, I can do it like this. And now it is implementing it and overriding this method. This looks correct here. This seems fine. And okay, so it's saying, and the second test we have to be able to put down money from ATM via credit card. So I can have a credit card name of test first. Name it as credit card, and then I can take a help of IntelliJ to basically create a credit class, and it would be in my coding folder. Okay, credit card is ID. I can implement that method that is required, and here I can simply copy and paste things from my debit card, which is just put down money from this, and have applied and have incurred. That's for now hard coded entered 200 as transaction charges. Because in credit card, if you put down money from using a credit card, right, then bank generally incur some charges from you. It could be 200, 500, anything, but yeah, that happens. I can take some help of done to from bank. I can have incurred 200 as a transaction charge. Or if you want, I can make 200 as a variable. I can name it as transaction charge. When I'm creating, let's create this as a field. Okay, and it should be a double. In the app, and in here I can say transaction charges, and it would be a double. I can just remove this from here. Like I have already used sync format, right? So I can take the help of sync format only, and I can simply have that transaction charge. Or if you want, we can make this as a field, and yeah, we can make it as a transaction charge field, and basically in while constructor we can initialize a credit card transaction charges also if you want. We can think of doing it in a more better way. Like we can create a setup for that if you want. In future, if you want to change the transaction charge, then we can do it via that. Okay, so as of initially it would be 200. Now, if you will go to a credit card test method, which is, and since here also you see it, bank ATM services just depending on bank card, which is a abstraction, and it is not directly this high level bank ATM service. It's not directly dependent on low level service or this credit card class. It is instead dependent on the abstraction. So in this way, we are basically adhering to our dependency injection principle and able to inject dependency of a bank card in our higher level service called bank ATM service. So it looks fine to me. Just learn that test and see. I think it should fail because the message we are getting is different. Let's see how it works. Yeah, so it failed because we are expecting this message. You can say withdraw an amount of this. I have entered. Yeah, also I can have a transaction charge too. Let's just have a transaction charge too, and I can say transaction charge, and I can set the transaction charge. Look, I can create the object of credit card. It's my credit card. I can just set the contents charge in my credit card. I can it as 500 now, right? And okay, not talking about it as 500 here, right? I put in a variable, I can use that 500 transaction, not the typo here, name to transaction charge here. I can just pass this transaction charge here, withdraw an amount from bank, and then have incurred. You can just paste this thing here, and have incurred. I can just have that float variable here, which is stated. So I can enter this much transaction charge, and I can simply pass my transaction charge here. And now it's a return a message like withdraw this, and I've entered 500 transaction charge, which is my this one, right? Can just have a space here. Let's see how it looks now. Oh yeah, here also. Yeah, fine, it works.